Morning, this is Josh at Mass Gunworks here in sunny, cold, snowy Converse, Indiana. I've had some questions about ways to hold rifle barrels in the lathe, and I've come up with some solutions, and I was going to share those with you. There's a guy named Kurt Vaughn who has a YouTube channel, Vaughn Precision, excellent gunsmith. This is partly inspired by a conversation I was having with him about holding rifle barrels that are too short to go through my headstock. So what we're going to do is I'm going to walk you through a couple different setups. One thing that I've had to learn to overcome is if I have a certain way to do something that I like, but the thing that I need to work on is not going to allow me to do it that way, I have to figure out a different way to do it, okay? Case in point, I need to thread a barrel, right? But it's too short for me to do it the way that I traditionally do it, okay? And the way that I traditionally was taught to do it is this way. So I pass the barrel through the headstock. I have a hollow spindle that turns this chuck. It's approximately 1.5 inches in diameter, and that gives me the ability to manipulate that barrel on the front and the back. And I use a dial indicator with a gauge pin or what they call a range rod in the bore of the barrel, and I want to try and get both ends of that barrel running true, or concentric is the technical term. So that's the way that I was taught to do this. So I'm going to have my camera person come in here real quick, and we're going to take a shot. And you can see that I have this held in a 4-jaw chuck. And I have roughly dialed it in with a 1/1000th indicator, where I didn't get it perfect because, you know, I'm not actually cutting, I'm just filming. This barrel's running about 2 to 3 thousandths to run out right now. I could get it down to, say, 2 to 3 tenths of a thousandth. So that's a really dialed in. So now I'll come around to the back, and on the back, this lathe is a Grizzly G0709. Yes, and it is a gunsmith specific lathe. One of the things that makes it a gunsmith specific lathe is it has this thing called a spider that's built into the spindle. Essentially, I have a 4-jaw chuck on the front and on the rear, okay? And this allows me through 4 points of contact to push this barrel up and down and side to side. And I can hang a dial indicator off of here, and I can dial this side in, and I can dial this side in. Or if I want, I can just use a pin, and I can do everything from the front. So, you know, there's lots of different ways. My limitation that I have, so this is a 27-inch barrel blank, okay? It's really not an issue for me to do this way in this lathe. But I'm going to take this barrel out. I'll show you a little problem. Find my chuck key. Slide this out the back. By the way, this is a 50 caliber barrel blank from Green Mountain Barrels. It is beautiful, and I am in the middle of a project. I'm going to build myself a bolt action based off a Savage 110 receiver, and we're going to build a 50 Action Express bolt action. It's going to be awesome. So we're going to set this aside. Right now. And okay, so we're going to measure through my headstock, and we're going to see what my limitation is here. Now, to do this properly, I have to be able to pass the barrel all the way through and I have to be able to get the end of it onto these spiders, okay? So I'm hooking the end of the bore, I'm measuring to the front of the jaws of the 4-jaw chuck. And I need at least probably 1.5 to 2 inches sticking out. That way I can safely work without getting my tool too close to my chuck and risk striking the chuck with the tool, which would completely ruin my day. So to the front face of the chuck, we're at exactly 21 3/8 of an inch long, okay? So I need about 23 inches of barrel to comfortably work in a manner that I feel safe to do it with this method, okay? So you ask, well, why does that matter? Well, riddle me this, Batman. Say we're threading an AR-15 barrel, okay? This barrel is 16.5 inches long. I'm 5 inches shy of being able to run through the headstock like I was taught to, okay? So the biggest thing that I have to overcome is how am I going to do this? All right, well, there are two different methods. One that I just kind of realized, and one that has kind of been a mainstay of how things are machined on a lathe since they were invented. It's called going between centers. So when you go between centers, and I'll set that up, you have a faceplate with a dead center and a live center or a dead center over here, and you're going to pinch your work in between 2 points. And typically you're going to find a hole in the center of either side, and that's where you're going to pinch it, okay? With an AR-15 barrel, that's a little difficult, because if you see inside that extension, I've got about a 1/2 inch of distance I have to overcome before I can get into the bore so I can have a good center point of rotation, okay? And they do make some different centers that would allow you to reach in there and overcome that, but it's probably not going to work real well with this one. So we're going to keep the camera running, and I am going to, as quickly as I can, get this changed over. This lathe has what is called a D1 style cam lock spindle. So instead of having a chuck that threads on, I have these cams that I turn, and they lock the chuck in place. The great thing about this is I don't have to worry about being careful when I'm wanting to turn something with the chuck going the counterclockwise, because there's no risk of the chuck spinning itself off of the threads that are holding it to the lathe. Okay, I'll show you the back of the chuck. This is called a D1.5, and the D1, I believe, is the type. Someone can correct me out there in YouTube land if I'm wrong. The next number is the size. Typically, you'll see like a D1.4 or D1.6. D1.4 has 3 pins, D1.6 has 6 pins, and a D1.5 is kind of like an in-between size. Okay, faceplate. Make sure we have all of our chips out of the way so we don't run into a concentricity issue, because we have a chip between the face of the plate and the nose of the spindle. That'll cause a problem, ruin your day. Put that on there. Because this is a demonstration, I'm not actually working. I'm not going to go run through tightening all the pins. Basically, what you want to do is you want to tighten them, and then we're going to go back around and just double check and make sure all good and tight. So with a 6-pin head, I typically do every other pin. in an order like I'm tightening lugs on a car wheel. So, I have two things. My spindle is a Morse Taper 5. I have a sleeve that's going to adapt from that to a Morse Taper 3. So I'm going to make sure these are good and clean. Slip them together. This is just a friction fit, okay? I'm going to slap that in there. So there's one center. Then we're going to get our live center. You could do this with a dead center on this end as well, but you would need to have some lubricant, okay, to keep from getting too hot, because since that center's dead, it's not moving, your part is, so you're creating a lot of friction, okay? There's two different types. I have a standard and a long reach. I use this one when I thread. But just for the purposes of demonstration, we're going to use this. So we're going to take our tailstock, put our center in, and I need a volunteer. As, you know what, we'll just use our barrel one again, because that's what it's there for. This is a different one. This is a 223 barrel blank. Probably going to use this for like a 22 250. So we're going to take that, put it in there. So I know you're thinking, well, how's it going to turn? Well, you have this thing called a drive dog. Okay, drive dog clamps around the outside of the object, and if you'll come over here and show the surface of that plate there. A little bit more. Okay, this is going to lock in right here, okay? As the lathe rotates, this dog is going to hold that barrel. I'll actually set this up so you can see how it works. Okay, so we're going to get this locked down. We're going to very, very gently feed this in until we find our hole right there. Okay. All right, so that is there. Lock this so this doesn't retract. Turn this around so we can get this tightened up. And typically I'll take a shim of wood or something and put it in between the drive dog and the top surface of the barrel, that way it doesn't mar it up. But essentially, that's how that works, okay? So as this turns here, I've got these in the bore, so this outside surface is running concentric as best as it can to the line of the bore. Now, when I'm cutting threads on a barrel to fit it into a receiver or to fit it for a muzzle brake or a suppressor, it is extremely critical that I am cutting my threads in line with the bore axis and not in line with whatever the outside of the barrel is running, okay? Because these barrels, some makers are great, some makers are so-so. You can have as much as 5 thousandths of run out on the outside surface as it compares to the bore, okay? So it's why you want to make sure that you're doing everything when you're cutting threads on a barrel based off the bore, all right? And this is an old school method. This has been around for thousands of years. This is how it's been done forever. Running it through the headstock is a relatively new method when you look at how long lathes have been in use, okay? It's a good method. It's a very good method. But, as I showed you before, I'm limited by the length of my headstock. So now we're going to move on to method number 3. And if any of you out there have questions or you have a method that you've come up with that works for you, please share in the comments. My biggest goal here is not to be like an ultimate purveyor of knowledge, but just to share things that I've learned and to give you guys a conversation starter. If you have something that has worked well for you in the past that you'd like to share with the group. Now, this is my public service announcement. I know not everybody's going to agree with me, and haters going to hate, all right? So keep it respectful. If you don't agree with what I'm doing, it is what it is. Don't make me feel like an idiot. You know, everybody's learning. Okay. So I've got a wood block here to protect my bedways. Take my surface plate off. Sorry, face plate, not surface plate. One thing that I forgot to incorporate into that setup, and I'll throw it in this next one, okay? This is called a steady rest, right? And I'll show you what this does here in a minute. But basically, this is going to provide a way to keep your work from wobbling, because as I move away from the supported end with my tool and I'm putting pressure in, it's going to start to bow my work, okay? It's going to be minimal on a piece of metal, okay, especially steel. You may not be able to see it with your naked eye, but it is there. This provides support somewhere in between my points and allows me to have minimal deflection, okay? So we're going to put this on. One thing I want to do before I do that is make sure that these ways are clear of chips, because this is going to ride on the ways. And the last thing I want to do is get some chips in the way and scratch up my bedways. Because the bedways are the life of your lathe. And if they suck, guess what? Your lathe sucks. Okay. So make sure that's good and clean. So this clamps down basically, and I can put it in any position I want. Within the limitations of the track on the bedway and the saddle here. So we got to pop this out, and I have a center getter outer tool. It doesn't take much force to pop these out. See? And then I don't like to keep these stuck together. So there we go. Pop these apart. I am going to switch to the long reach center for this one because this is how I typically do this. And I want to show you the way that I truly do it and not just simulate. Okay, so these are called 5C collets. All right, they are made to grip round parts, and they're pretty stinking accurate. My collet chuck that I don't have a collet closer. That's a lever that holds back here and it runs through and it like sucks the collet into the headstock, okay? I went the less expensive route, and I got one of these collet chucks, and I have been able to consistently, trying to find my witness marks, dial this chuck in within less than 1/2 of run out based on the nose of the chuck. And again, I'm just going to tighten 2 of these because this is just a demonstration. So, I'm going to get my calipers. Okay, the limitation here is these collets are only going to flex, say, 5 thou. So if I have a part that I want to hold that is 745 thousandths, so it's 5 thousandths shy of being exactly 3/4 of an inch, I can most likely grip that with a 3/4 inch collet, okay, because I've got a little bit of give there. So this AR-15 barrel, as we've stated, is too short to go through my headstock. And because of this barrel extension, it is probably not a really good idea for me to try and run it between centers, just because I'm not getting good contact with the actual bore axis, okay? Now, that being said, this extension is threaded and tightly fitted to this barrel, okay? This surface needs to be in line with the bore axis, okay? So if I grip here, in theory, and this has proved out to be true for me many times, I am gripping something that is close enough to concentric with this bore axis that I'm not going to have a huge risk of something on this end being off from the axis of the bore, okay? So the trick is I need to have the right size collet. So what size do we want? So I have Cerakoted this. Actually, my son Cerakoted it. He did a great job. Right now, I am looking at, put that back where it was. 1 inch and 1.5 thousandths, okay? So I happen to have a 1 inch collet. It is in this collet chuck now. So I'm going to open up my steady rest. I'm going to take this barrel and I'm going to put it in this collet chuck, okay? And we're going to get that up close to that pin right there, the indexes. That way, you know, you put that in straight every time. And we're going to tighten down our collet chuck. Okay, now, I do not in any way, shape, or form just want to leave the rest of it to chance. So, I'm going to put my live center in here. Now, I'm not going to cram it in there, okay? I'm going to just get it seated. Okay. Now, it did move just a little bit. But what I've done is I have essentially mounted this barrel between centers. Okay, this is just a different method, same concept. And because I'm going to be working on this end, and I should have done this earlier when I set up the other barrel so you get the full monty, but we're going to take this and say I've got my threading tool in here. Okay. Say I've got my threading tool in here. Run this in. And you can see, I'm only working on the front half inch of the barrel. You can see that I've got sufficient room, okay? I got sufficient room to work, even with this thing here. So what this does, it's got some bearings on it to rotate. I'm sure a lot of you are getting bored by this because you're like, I know. I run a lathe, I'm a machinist, blah, blah, blah. Yes, some of us are not. We need visuals. So we run these down until they just start to rotate. Typically, you're going to start with the ones on the bottom, do the top and last. I did it backwards. Sue me. Okay. And we are supported. Okay, I've got some lock screws that can lock that in place. So, that being said, I can take the center out if I need to, and I can work on that, and it'll be in there. Just to further demonstrate this, I still have my 1000 indicator. Let me be clear about something. If I am working on a rifle and I want to have an extremely high degree of accuracy, I will dial this in to tenths. Okay. If I am working on a barrel and I am simply fitting it for a suppressor, or I am this may not work out too well. Fortunately, my thingy here is in the way. Where I am putting muzzle brake on it, if it's not a rifle that requires extreme precision, like somebody's, want to shoot a 1,000-yard competition, they got an AR or a 300 blackout that they're only going to shoot out to 200 yards. I will dial this in to a half of a thou. That way that I ensure that I am not going to have a baffle strike. Okay, baffle strikes are bad. They will destroy your suppressor, and if you're the gunsmith that did that unfortunate work, you're in trouble, Jimmy, because you potentially put someone's life in danger, and they will sue you. Okay, so got the range rod. Now, we have put our barrel between centers, and I have run this rod in the bore. And my goal here is just to show you how close I am just by supporting it with the steady rest and that collet. And I've used the live center as a reference point. Get the other end. Let me get that on 0 if I can. I'm sorry, I'm a little anal. Okay, so we may see 1 to 2 thou of run out. But as soon as I pop that live center back in there, that's going to go away. Over here, cameraman focusing on the dial indicator, and we're going to pray and hope that we don't look stupid. Okay, do you see how little run out we have. I am less than 1,000th. And I know that the camera may not be able to pick that up, but I'm probably between 1/2 and 3/4 of a thou using this setup. Okay, so let's go ahead and trade places. Go ahead and back up so you get the whole thing in view. So anyway, the point of this whole video here was I just wanted to show an alternate method for holding a barrel in a way that will allow you to cut accurate threads, or accurate enough, so you're not, causing a baffle strike on a suppressor, which honestly, that's my biggest worry. So I try to do every barrel the same way every time, okay? This may or may not be accurate enough for you if you're wanting to do chambering. I have collets that are big enough that I can fit a Savage barrel in there. It's a 1.055 by 20 thread, and I don't remember what nominal size 1.055 is. I want to say it's like 1/32 ish, but I have a collet that's that size, and I can hold a Savage barrel in there by the tenon, put a center in, thread it. I have had to work on some Savage barrels where the customer wasn't threaded. I have to cut it down to 19 inches before I can do the thread. I'm not going to fit through my headstock. I'm not going to be able to dial in like I was taught. Same thing with a Remington. Okay, a Remington is a 1.1/16 by 16 thread. Okay, I have an 1.1/16 5C collet specifically for that. And again, because of the diameter of the barrel profile, I have to cut the barrel down so I have enough meat on the end to put the threads on. Now I can't go through my headstock. Now I have a problem. This setup right here is quick, it's reliable, and it's consistent. Okay, that's the biggest thing. And I've got about 2 to 3 thousandths of Cerakote on the end of this extension. If this was a fresh barrel with no Cerakote on it, it would probably have less run out. Okay, but anyway, you get the idea. So again, if you have questions, comments, want to start a discussion, feel free to leave it in the comments below this video. My email is mastgunworks, MASTGUNWORKS @gmail.com. Feel free to email me questions. I'm no expert. I'm learning like everybody else, but this is something I found that works great. So until next time, I have some other things that I plan to throw out there. I just got a multi-fix tool post for this baby. I'm going to be selling this Aloris style potentially, and all my tooling that goes with it. So if you need a tool post, send me an email and I'll be more than happy to make you a deal. This is my milling machine. I know I've done some videos with it in the past. This is a Wells Index 645. I've recently learned some neat things about it that I didn't know, and I'm going to make some videos about the different features that are on it right now. So, and I briefly exposed the Tormach PCNC 1100 that I have over there, and I'm still in the process of learning. God love John Saunders, NYC CNC. He's a great teacher. I'm still mucking through learning Fusion 360 and CAM, and when I get better at that, I'll start making some videos about cranking out parts on that. So thank you guys that have been following me and subscribing to the channel. If this was helpful, hit the like button. Love to have you subscribe. So we'll see you next time.